Our planet is getting hotter, and as a result, the world we know and the way we live our lives will change. Many scientists believe we're heading for at least a 3-degree warmer world by the end of this century. For some, the effects of global warming have already begun. Based on the work of leading scientists, we peer into our future to discover what our world will be like with a temperature rise of 1 degree.
That may not seem like much, but that temperature change can then affect so many other things.
2 degrees.
2-degree increase in temperature could make life very, very difficult on this planet.
And 3 degrees.
We're not just talking about messing up the next 10 generations. We're talking about changing the Earth system for 100,000 years.
Can we slow down global warming? How could science help us fight back? And what kind of future Earth will our children inherit? I'm Iain Stewart. Through my work as a scientist and TV presenter, I've been lucky enough to see some of the most incredible places in the world. Places that, if global temperatures continue to rise, will change beyond recognition. Some may even disappear. I believe that human actions are driving global warming, and I'm not alone. I'll be talking to some leading climate scientists to get the latest facts, opinions and concerns about the future of our planet. And I'll be joined by Professor Kathy Sykes, who discovers it's not all doom and gloom.
I'll be looking at the science and technology that could help us cope with living with the consequences of a warmer climate.
The Earth's climate has always changed, but rarely this fast. In the last 250 years, the planet has warmed by nearly 1 degree Celsius. Most climate scientists agree the only reasonable explanation is the higher levels of greenhouse gases like carbon dioxide and methane in our atmosphere. When we burn fossil fuels, we produce gases that act like a blanket around the planet, trapping in heat. Evidence that links temperature rise to carbon dioxide levels comes from projects like this one, just 700 miles from the South Pole, run by Dr. Robert Mulvaney.
The type of work we do is we go to the Antarctic and we drill deep into the Antarctic ice sheet, bring what we call ice cores back to the UK for analysis, and by looking at the analysis of the ice we can understand how the atmosphere and how the climate of the past has been developing over up to 750,000 years.
This ice core is 750,000 years long. It holds unique information about our past climate cycles.
If we go back 750,000 years, that's our deepest ice core that we've worked with, we can see 8 climate cycles. So that's 8 times we've gone in and out of an ice age. So if we look at those 8 climate cycles, we can see what the temperature was doing. But critically also, we can get at the carbon dioxide, the methane, these 2 greenhouse gases. We can see what levels they were in the ice. And what we find is they're actually remarkably consistent with temperature. They track temperature extremely well.
Back in his lab, Rob is able to examine a younger section of the ice core. It's got air from the 18th century, before the Industrial Revolution, trapped in its frozen bubbles.
I've got a small section of ice here, but what I'm going to just do is just take my gloves off and warm it up. Once I've warmed it up, you ought to be able to see the air bubbles in the ice. So about 10% of the volume of the ice core is air. I can hear it crackling away as the little tiny air bubbles that are under pressure because they're from deep in the ice sheet are all bursting as the ice melts around them.
Melting the ice in an airtight bag releases its ancient air for analysis.
So this is pre-industrial air, and what we're hoping to see is what the level of carbon dioxide is in the air before man started using vast amounts of fossil fuels and pouring carbon dioxide into the atmosphere. And then wait for the instrument to stabilise. So I've got 288 parts per million.
find out how that figure compares to today's levels of greenhouse gases, Rob took to the skies with Kathy. Wherever CO2 is released, it disperses evenly across the globe, so its concentration should be the same over the UK as over the Antarctic.
We brought us up in the hot air balloon to get away from all the industrial pollution into fairly clean air.
So this is about the cleanest
About
we
as
should
clean as
expect.
we, yeah. And what we're getting is 386 parts per million.
It's gone up.
We're at 386.
386.
Yeah.
Now, what about all those people who say, oh, there's changes over geological time, we don't need to worry, the world will correct itself?
Well, that's the point of the ice cores. Over the last 750,000 years, we've been in and out of ice ages 8 times. Yeah. Carbon dioxide has never been above 290 parts per million.
Now it's at 386.
Yes.
That's a serious rise.
That's a serious rise, and the critical thing is that how fast it's rising. Normally, we'd expect 30 parts per million rise in about 1,000 years as you come out of an ice age. In the last 17 years, the atmosphere's risen 30 parts per million.
OK, so in just 17 years, we've seen changes we'd expect to have taken 1,000 years.
If it was just a natural way, a natural climate.
So as a climate scientist, you're completely convinced?
I'm completely convinced that the carbon dioxide is coming from burning of fossil fuels, and I'm completely convinced this will lead to a change in the climate.
It's time to worry.
It's time to worry.
Today's temperature is already 0.7 degrees warmer than the pre-industrial average, and we're fast heading to a 1 degree warmer world. 70% of the planet is covered in water, and as the oceans heat up, we're seeing small but significant changes. Studying them is Californian marine biologist Tierney Tees. Tierney's research is focused on the magnificent ocean sunfish, or mola mola, common to Californian, Caribbean and Mediterranean waters. By tagging them, Tierney can discover how they're responding to climate change.
One of the things we're interested in looking at is to see if we're getting range extensions into more northern waters than what we've traditionally known.
Nice. Good stick.
Once attached, the tag records information for 9 months before being automatically released.
The tag floats to the surface and uploads all its data to satellite. That satellite relays it down to our computers, and from there we can analyze all that data.
1, 2, 3, I'll push down.
Climate change is much more than, oh, it's a little hot in the ocean. Because adding that amount of heat, 1 degree, you're changing all manner of things. You can change the oxygen levels, you can change the nutrient levels, you can change circulation patterns. Climate change is changing a whole bunch of things simultaneously.
Research is in its early stages, but a clearer picture of the sunfish's new range is emerging.
Off the Cornish coast and in areas around the UK, certainly there have been increased populations of sunfish.
In Cornwall, local conservationist and tour guide Rory Goodall makes a living from showing tourists just how the local waters have changed.
There have always been pleasure trips here in Cornwall, but over the last few years we've noticed more and more interest in wildlife. We've got lots of dolphins, whales and other sea creatures here, and more we're seeing tropical fish turning up, which is quite exciting, of course, for everybody. I mean, they don't need to go to the Caribbean now to see sunfish. They're virtually, guaranteed to see them every time they come out on a trip with us in summer. Well, what we tell our passengers is to look out for a fish that's waving at you.
These grow to 13 feet in diameter. Blimey. He's fine, he'll be all right. We'll put him back. He's not very happy, obviously. But what a fish.
It's great to see these exotic creatures off our coastlines, but they do represent a worrying shift in the balance of nature. Evidence of this shift can be seen right across the globe. Coral reefs, home to a quarter of all marine life, are dying as the oceans absorb more carbon dioxide, making them more acidic. In Africa, the annual migration of over 1 million wildebeest is under threat as drought decimates the grasslands they feed on. While the near 1 degree rise in average temperature threatens the survival of some species, it allows others to thrive. In Canada, the tiny mountain pine beetle is responsible for devastating an area of forest bigger than England. The beetles, no longer kept in check by winter temperatures, are killing the evergreens and turning them red. Worries over warming led the United Nations to set up a body called the IPCC, the Intergovernmental Panel on Climate Change, a group that represents the findings of more than 4,000 scientists. Nobel Prize-winning Dr. Rajendra Pachauri is head of the IPCC, and he's the man that world leaders turn to for information. And I went to meet him at his home in New Delhi. A lot of people in the UK think a 1 degree temperature rise isn't that bad.
I agree. A degree increase in temperature may not seem like a lot, and perhaps, we've had fluctuations in temperature through the years. You get bad summers, bad winters. But you see, what we have to worry about is all that accompanies that increase in temperature. We will have, and we are having, many more heat waves. We have far more severe floods and droughts. Unfortunately, this is going to make it very difficult for some species to survive. There are some parts of the world where the impacts of climate change are going to be far more serious. For instance, the Arctic region is actually warming at twice the rate of the rest of the globe.
One of the main reasons for this is that white surfaces reflect heat and dark surfaces absorb it. As the Arctic warms, its ice melts, exposing the dark sea underneath. The albedo effect. It's here in the Northwest Passage that this change is most evident. The passage is a frozen expanse of sea ice off the northern shore of North America. In 2007, something extraordinary happened. The Arctic summer sea ice broke up and melted away at an unprecedented rate, leaving nearly a quarter less than in any previous recorded year. The sea ice retreats every summer, but in 2007, so much disappeared that for the first time ever, large ships could navigate through the Northwest Passage. Since then, the average loss of sea ice has been 40% more than predicted by even the most pessimistic climate models. If this rate of shrinkage continues, there will be no summer sea ice in the Arctic by 2040. And that is a serious problem for the wildlife. For 28 years, US Geological Survey biologist Steve Amstrup has been spending his winters in the Alaskan Arctic. He's been studying one of the most magnificent animals on the planet. The polar bear is the largest carnivore on land. Successfully adapted to living in this unforgiving wilderness for the last 300,000 years, it cannot adapt to climate change. As one bear already has a number on its back, Steve knows it's been tagged and studied. So using a tranquilizer dart, he sedates the other, a female.
What we're trying to do is to understand the welfare of the population and to look into the future to see what the future welfare of this population is likely to be.
Steve has about an hour to do a number of tests to assess the size and health of the animal before the sedation wears off.
Well, this is just to get different measurements, and this is a total girth. So it looks like 120.3. Heart girth? Yep.
His research has revealed that many polar bears are becoming malnourished.
Polar bears depend entirely for their nutrition on seals that they catch from the surface of this ice. They can't catch them on land, and they can't catch them in the open water, and therefore they're entirely dependent on the sea ice for their survival. And our big concern right now is the sea ice in this part of the world has been declining at a rapid rate.
This bear is producing milk, but she has no cubs.
So what's happened is she's lost her cubs a while ago, and now she's in heat again. And so that means that she came out of a den someplace along the coast this spring, lost her cubs.
In recent years, Steve has seen a big fall in the number of cubs surviving their first year. His findings helped lead the US government to classify polar bears as a threatened species.
45. Our forecast suggests that polar bears could be gone from this region where we're standing right now within the next 50 years. I've been coming up here for 28 years, and I've always been able to count on finding polar bears. If I were to live to the day where I couldn't come up here and see polar bears, that would be pretty hard for me to take.
In spite of the way she looks, it won't be long before the bear fully recovers. Do you think we're looking at an ice-free Arctic in summer in the next few decades?
Entirely possible. In fact, we have pointed that out very clearly because ice cover over the Arctic by even the 2050s would be reduced substantially. And therefore, if we don't do anything about the problem, certainly within this century, we would have an Arctic region where perhaps you could play cricket.
So what convinces you that global warming is very likely caused by human actions?
Science has reached a level of sophistication and reliability which really leaves no room at all for doubting. Our use of fossil fuels ever since industrialization began has been a primary contributor to the increase in concentration of greenhouse gases in the Earth's atmosphere.
Over a quarter of the greenhouse gases we produce come from fossil fuels burned to generate electricity. Coal, oil and natural gas power almost every aspect of our lifestyles, and we show few signs of cutting back. It's coal which is both the dirtiest and the most commonly used. It powers a staggering 40% of worldwide electricity generation, and its use is growing, especially in the developing world. In recent years, China has been building 2 large coal-fired power stations every month.
The developing world, I'm afraid, really doesn't have a choice but to use coal for power generation, but to consume more and more energy for industrializing and increasing their incomes.
And what about the argument that I hear all the time, which is that in the West, we don't need to change our lifestyles because it's pointless because the emerging industrial nations of India and China are going to, outcompete in terms of carbon dioxide emissions?
Well, I would say that's an extremely irresponsible stand because, firstly, the developed world has used very energy-intensive forms of production ever since industrialization began. And they've reached a level of prosperity which clearly everybody in the world aspires to, and they have a right to do that. Why should they not? Well, there are 1.6 billion people. That's a quarter of humanity that has no access to electricity today. People don't have a light bulb in their homes, 1.6 billion people. Now, we can't possibly tell them that you'll have to do without electric lighting all your lives or your children's lives.
So we need to come up with alternatives to fossil fuels, or find a way of burning them without releasing the emissions, which is why I've come to Beulah in North Dakota. This coal-fired power plant is actually capturing its carbon dioxide before it reaches the atmosphere. This is the first stage of a technology called carbon capture and storage. These pipes are full of captured CO2. But the real challenge is what to do with it next. Every year, 12 billion tonnes of CO2 are produced by the world's power stations. The layer just above is much denser, so the idea is the carbon dioxide gets trapped here. Nobody's planning to do this in a canyon. Instead, they'll do it at least a kilometre underground. If the natural rock seals hold the CO2 and keep it held, the potential for geological storage is vast. Sandstone could store 50 years of Utah's emissions, a state of 2.5 million people. There are different kinds of geological storage sites that could also work, but the CO2 still has to get there.
Carbon dioxide is expensive to transport, but since coal and gas are often found in or near rocks like these, many power stations are already built right on top of places you could store the CO2.
In 2010, 1 million tonnes of CO2, the equivalent annual emissions of a small power station, will be injected into Utah sandstone.
Carbon capture and storage could allow us to carry on using fossil fuels like coal while we develop cleaner, emission-free technologies. But at the current rate of development, widespread use is still at least 10 years away. And that may be too late.
If we want to limit temperature increase to around 2 degrees Celsius, then we have only 7 years more in which we may allow emissions to increase. But beyond 2015, they'll have to start declining.
And what does a 2-degree world look like?
It doesn't look very good. I mean, with 2 degrees, we certainly will get very high sea levels over a period of time. Sea level by thermal expansion alone will be anywhere from 0.4 to 1.4 meters.
And it's not just the physical rise of the sea, is it? It's what comes with that in terms of the storm surges or increased hurricane destruction as well.
Absolutely. It's now apparent that in some regions of the world, the warming of the ocean leads to much more severe hurricanes or cyclones, because when you have a warmer surface of the ocean, you get much greater evaporation of water, and that, in a sense, provides the fuel, provides the strength to a hurricane or a cyclone.
The destructive impact of these more intense hurricanes will affect places we assume would be safe. New York, 8 million people, one of the biggest and richest cities in the world. In a 2-degree warmer world, it's predicted that this city is more likely to suffer from catastrophic flooding because of a storm surge caused by a hurricane. Vital evidence for this is found outside New York City. Jeff Donnelly is a paleotempestologist, a scientist who studies ancient storms. Like climate scientists in Antarctica, he does this by digging down into the Earth's history and taking core samples. They reveal that New York has been hit by storm surges before. A storm surge is like a tsunami whipped up by high winds and extremely low pressure in the eye of the hurricane. It's usually the most destructive element of a hurricane strike.
This gives us some sense for how often a place like New York City has been hit by big hurricanes in the past. It's basically like reading a book. We're just going back through time. And so we split these open, and you can see that this is the organic rich sediment that's being deposited day in, day out. Occasionally, though, as we move further down the core, you've got these large sand layers that are deposited. And these sand layers are the result of storm surge overtopping the beach and washing sand into these ponds and marshes. And this very large layer here dates to the 1938 hurricane in New England. These cores here are actually from very near New York City. It was likely laid down by the 1821 hurricane. And here that dates to 1635. And then prior to that, these are all prior to European settlement of Eastern North America. So they're all undocumented hurricanes that go further back in time. So we know, direct hurricane strikes, intense hurricane strikes in New York are possible. They've occurred many times in the past, and they're going to occur again in the future.
Previously, in any given year, there was a 1 in 100 chance that a devastating 10-foot storm surge would hit. But in a 2-degree warmer world, those odds will change. leading climate scientist Dr. Cynthia Rosenzweig has done intensive modelling to predict storm surge floods.
One part of the climate change projections that is virtually certain is that the sea levels will be higher. That provides the base from which coastal flooding occurs.
Even if the storms don't change, having those higher sea levels really allows the flooding to go inland further. That is the number one vulnerability of lower Manhattan and many low-lying areas in the New York region.
With higher sea levels, storm surges that would have caused minor flooding in the past will become as destructive as the big, once-in-a-century storms.
What our modeling shows is that this very intense 1 in 100-year storm could occur once in every 20 years.
In our children's lifetime, it is very likely that this catastrophic storm will occur.
The New York Stock Exchange and Wall Street and all of Lower Manhattan would be devastated. The outer boroughs, Staten Island, Queens, Brooklyn and parts of New Jersey would also be swamped. But there is a way to limit the damage. Engineers have planned for 3 locations, barriers similar to those on the River Thames. If built, they could look like this. But it's estimated that they would only protect half of the New York metropolitan area. Elsewhere in the world, the reality of sea level rise is already being felt. The South Pacific island state of Tuvalu regularly experiences flooding. Only a small further rise in sea level could wipe this nation off the map as the islands disappear beneath the sea. Bangladesh already suffers severe flooding and river erosion and is forecast to be devastated by climate change within 40 years. It's likely that 35 million Bangladeshis will become climate refugees, at risk from famine, disease and political unrest.
There is no immunity from the impacts of climate change. Even the most prosperous societies are extremely vulnerable to the impacts of climate change. An example of that is what happened with Hurricane Katrina in the city of New Orleans.
And what about Europe in terms of extreme weather? What can we expect?
Well, Europe is particularly vulnerable. You certainly will have more heat waves, as we've seen in the past few years. You'll get floods in odd places at odd times of the year. There will be droughts. Some parts of Europe are very vulnerable to that. And we certainly have a serious problem with water availability in the Mediterranean region.
Some scientists believe Europe has already begun to experience the impact of global warming. In 2003, unprecedented heat waves killed over 52,000 people. In 2008, Spain suffered its worst drought since records began 60 years ago, and it's predicted to get much worse. There's evidence that in a 2-degree warmer world, the dry conditions of the Sahara will effectively be moving northward to the Mediterranean. Popular tourist destinations could become deserted as soaring temperatures bring more heat waves and droughts. And with drought comes fire. This year, parts of Europe were devastated by wildfire. Greece alone lost over 51,000 acres of vegetation, vital for the natural removal of carbon dioxide from the atmosphere. And it's not just the European continent that's been hit recently. In 2008, California also experienced its worst wildfires since records began.
This is our nightmare.
I'm just scared. My kids and my grandkids, I'm just scared.
It's just unbelievable when you see all those flames coming right at you.
There were over 9,800 of them, burning over 1.3 million acres and destroying nearly 1,500 homes. Professor Anthony Westerling is a wildfire climatologist. His research has revealed that what happened in 2008 is part of a worrying trend.
In the western United States, in the last 3 or 4 decades, we've seen an increase in spring and summer temperatures, in particular a little bit less than 1 degree Celsius. And these have very strongly driven increases in wildfire. There has been a tremendous and dramatic increase in the length of the fire season, well over 2 months in duration. Half of that increase has occurred at the beginning of the fire season and half at the end. So fires are burning much later into the fall and they're starting much earlier in the spring. And that is very easy to link to climate change.
In a 2-degree warmer world, fires, the spread of deserts, heat waves or droughts will become more commonplace. And for some people, the extreme effects of temperature increase will become a matter of life or death.
25% of the population in Africa is already living in a state of water stress. By 2020, as early as that, we're going to see 75 to 250 million people being affected by water stress as a result of climate change.
You know, I'm someone who accepts absolutely the reality of climate change, and yet I'm still really not sure what I as an individual can do about it.
Well, I think first we need to change our value systems and our lifestyles. 80% of the emissions of greenhouse gases originate in households, whether it's the appliances that you use and their production and so on. This is where I think renewables can make an enormous difference. We can use solar energy, we can use wind, we can use biomass in modern ways. We certainly can go in for biofuels that don't conflict with food supply. It's obvious that depending on the resources that exist in a particular location, you'll have to use a technology that's entirely suitable for that region.
Some countries are already leading the way to break dependency on fossil fuels. Here in Spain, they're harnessing the power of their most abundant resource, the sun.
Right beneath me is one of the world's biggest and most advanced solar power stations. It's called Andasol, and it's about 2 kilometres square. And you can see gleaming mirrors stretching line after line after line.
Although it's still under construction, a third of this power station is already working.
It delivers power to around 50,000 homes, enough for a town. And it avoids creating over 150 million kilos of CO2. Dr. Luis Crespo, you've been pioneering solar power here in Spain for over 30 years, and this is the result. You must be very proud.
Yes, we are very proud of looking around and seeing this plant being built in Spain. Spain is probably right now the leader in developing this type of technology all around the world, and this is the first power plant of this type being built in Europe.
The principle is simple. These mirrors reflect sunlight onto tubes containing a synthetic oil, which heats up and is used to create steam, which generates electricity. But the clever bit is that this solar energy can be stored for use when the sun isn't shining. The hot oil also heats up molten salt, kept in these vats, which act like giant storage heaters.
So at the end of a really hot day, this will be full of hot molten salt, ready and charged to be used for electricity.
Right. If we decide to produce electricity after the sunset, we will simply give this thermal energy to the steam generator and we'll produce steam, and the steam will move the turbine, and turbine will move the alternator, and finally we'll get electricity at the end of the day.
So we can have electricity during the day when it's sunny and during the night when there's no sunshine.
That's right.
Imagine if solar power could be scaled up. Huge areas of uninhabitable land could be filled with panels just like these. Research has shown that using less than 0.3% of desert area in the Middle East and North Africa could provide enough power not only for them, but for the whole of Europe.
The thing that I think is really exciting about this technology is that in the sunny countries, you harness the solar energy. In the windy places, you harness wind energy, so that all those countries coming together get sustainable power that can be relied on.
Not surprisingly, here in the UK, we'll harness wind energy. In fact, we're building the biggest wind farm in the world with 271 turbines. The London array will provide power for 750,000 people. In Portugal, the world's first ocean wave farm has been launched. The Pelamis, designed in the UK, uses the snake-like movements of its jointed sections to create electricity. Though not a true renewable, and despite its controversial reputation, nuclear power is undergoing a resurgence. It provides France with over 75% of its electricity, and here in the UK, the government is planning a new generation of plants. One country that already gets 99.9% of its power from renewable sources is Iceland.
But not for cars. Globally, cars account for around 1/10 of CO2 emissions, and Iceland has more cars per person than almost any other country. Now, it's trialling a new technology that may make gas guzzlers here a thing of the past.
I'm driving that technology. This may look like a normal car, but in its engine, it's got something special. It runs on hydrogen.
Once in the engine, a fuel cell splits the hydrogen into one proton and one electron, its basic components. The electrons travel through a circuit, producing an electric current which powers the engine. Here in Iceland, they believe fuel cells are an improvement on the conventional batteries that power existing electric cars, as they take minutes, not hours, to charge. And a hydrogen-filled tank has the same range as a petrol car. What's special about hydrogen technology is that the only emission from the car is H2O.
It is water. Taste of absolutely nothing. Amazing.
There are, however, considerable hurdles for hydrogen cars to overcome. Making hydrogen takes a lot of energy, and huge investment is needed before they become viable. Altogether, transportation accounts for around 1/4 of greenhouse gases, so we need to develop cleaner cars. But the fastest growing source of transport emissions is air travel, especially short-haul and internal flights. Replacing these will require a different approach. In Shanghai, China, they could have already found one.
I'm just about to catch this train. It's no ordinary train. It probably represents the biggest leap in innovation since railways were first invented. This is the first high-speed commercial maglev in the world. Maglev just means magnetic levitation, so it literally floats on air. From Shanghai Airport to the city, it's about 30 kilometres. In this train, it's going to take less than 8 minutes. If I were in a car, it would be over an hour.
It speeds along at 431 kilometres an hour. And it's all done by magnets.
Magnets can attract or repel, and this glass is floating because this magnet here is repelling this magnet here. And this train works on the same principle. Underneath the train, there are magnets that are held apart from the rail because that's got magnets in as well. And so the train levitates.
Once off the ground, the train is accelerated or slowed down by another magnetic field. And because the train isn't actually in contact with the rails, there's no friction, which allows it to travel very fast.
And also, there's no engine. So that means the train isn't emitting any greenhouse gases.
Unfortunately, the electromagnetic guide rails still need power. And in China, that power is provided by coal. Also, the initial cost of setting up a maglev network is huge. But there could be real benefits from replacing internal flights. Imagine if we could build our cities from scratch, bringing together all the technologies available. Rising from the deserts of the United Arab Emirates is the eco-city of Masdar. 90,000 people will live and work here. The city will be powered by clean technologies, so it will be carbon neutral. There will be no cars in Masdar. Instead, its residents will be zipping around in driverless pods and zero-carbon trains. Mazda should be completed by 2016 and offers an inspiring vision of the future.
Unfortunately, there's a source of greenhouse gas that these technologies cannot help us with. It's estimated that a staggering 18% of greenhouse gases comes from the global livestock industry. That's more than all the world's transport systems. Huge amounts of energy are needed to make the animal feed and to transport and refrigerate the meat and dairy. And as demand grows, more and more land is being cleared for grazing. In fact, a third of the Earth's surface is devoted to livestock. It's claimed that the biggest single contribution that we can make to reduce global warming is to go vegetarian. But that is a big ask.
If you can't bear the idea of life without steak or burgers, there is some hope. It's just that the meat wouldn't come from cows in the way that we're used to.
At the University of Western Australia, a strange creation has been slowly growing in a lab. Oren Katz works in the Biological Sciences department, and he's been making some of the world's first artificial meat.
When we grow those cells, we actually tend to refer to them, we coin the term semi-living, because they're not fully alive, they're not an animal, but they are a living part of an animal sustained in an artificial environment.
This artificial meat was grown from animal muscle cells. Cell cultures were formed in a microgravity bioreactor, a machine which rotates, evening out gravity. Without it, the meat would be a film just a few cells thick. Oren is now looking for ways of giving the meat more texture.
Research which is being taken place at the moment in trying to find ways in which you can exercise those muscle cells so they would align and have a more of a muscle-like texture. And there's two ways that can be done. One is by electrically stimulating those cells, or the second way is to try and exercise them physically, trying to build tiny exercise machines, tiny gyms for those cells to grow and become more like muscle.
We've brought this unique piece of engineered meat to the UK, to one of the world's greatest chefs. With 3 Michelin stars, Heston Blumenthal is famous for his fusion of science and gastronomy. This meat is so novel that here in the UK it's not recognised as food, so it can't be cooked or eaten.
It reminds me of something.
What does it remind you of? Let's smell.
Liver. Smells of raw liver.
I mean, the texture is more like liver than it is meat, isn't it?
It's like a baby slug.
Heston doesn't seem to struggle with the idea of meat grown in a lab.
I think as a catalyst for conversation, debate and thought, it's fantastic because how many people are quite happy to eat sliced ham that actually is not ham at all? That's not a problem, but something that's been grown in a lab actually is a problem. To me, that has the potential to be a lot more ethical, to have something developed that you know is from a clean source.
And reduces the amount of
And reduces the carbon
methane
footprint,
yep.
Then, yeah, this might be one of the most surreal things I've ever seen, food-wise.
Hey, well, that's quite an achievement.
This technology is still in its infancy. Currently, scientists can only make tiny jelly-like blobs of meat, not steak or chicken breasts, and the cost is prohibitively expensive. Artificial meat is decades away, but there's another technology that also mimics nature and could be ready sooner. Artificial trees. Trees absorb carbon dioxide, but they release it during the night and when they decompose. So Professor Klaus Lackner and engineer Alan Wright have been designing a tree which could be more efficient than the real thing. It was here, at Biosphere 2 in Arizona, that the idea was first conceived. Biosphere 2 was the largest, completely airtight artificial ecosystem ever built, the perfect place to study how changes in carbon dioxide would affect the planet. After working on several prototypes, Klaus and Alan now think they might have finally cracked it. This was an early design, more like a cabinet than a tree. Inside, a plastic that absorbs CO2.
These plastics are ion exchange resins, which are commonly used in water preparation. If you desalinate water or make deionized water, this is the kind of stuff you would use. You can buy it commercially in large quantities.
At first, they used chemicals to wash the CO2 out of the plastic so it could be reused. But this needed too much energy to be viable. Then they made a discovery that was quite simple.
When we take the bell jar off.
It happened after they'd set up a basic experiment using nothing more than an airtight bell jar hooked up to a carbon dioxide monitor. An experiment they repeated for me.
Here on top you see the plastic material which absorbs the CO2. It has been wrapped in thin strips around the frame.
The level of CO2 in the bell jar starts at 386, today's atmospheric levels. As expected, the plastic immediately absorbs it. So
Yes.
the levels of CO2 in here are really low, now releasing the CO2 that was previously trapped.
Yes. When it's wet, it doesn't want the CO2, so it pushes it off.
It's as simple as that.
It's as simple as that. It's amazing.
It is, and then you can dry it out again.
And when it dries out again, it will grab more CO2.
We'll do this over and over and over and over
And
again.
you can literally do this hundreds and hundreds of times.
Having ensured that rainfall will not release the CO2, Alan and Klaus are now building a full-scale artificial tree. When finished, it will have a central drum with panels of the special plastic and a humidity control system. By altering the moisture levels, it will absorb and then release the CO2 for storage. This process requires no chemicals, only a very small amount of energy and a water supply.
The vision of the future for these kind of artificial trees is that they can capture the carbon dioxide nobody else can capture. That's their advantage, that is their strength.
They estimate that a single tree will absorb about a ton of CO2 a day, about 75 cars worth. 60 million trees could potentially absorb all the CO2 we currently emit. And that's not all.
This is one of the few options available to actually go back and reduce the carbon dioxide level in the atmosphere from the level we are already at or will be in 50 years from now, back down to where it is safe.
All this absorbed carbon dioxide would of course need to be put somewhere. But that's where other new technologies come in, like the geological storage of CO2 that's being tested in Utah. And because CO2 levels are the same around the planet, a great forest of artificial trees could be placed right on top of storage sites, so the CO2 wouldn't have to be transported.
This all sounds really promising, but scientists believe that even if we change our behaviour immediately and utilise new technologies, we're still likely to hit a 2-degree temperature rise by 2050. But if measures like these are not adopted and we continue on our current path, then temperatures are predicted to rise to 3 degrees above the pre-industrial average by the end of the century. And that, according to Professor Peter Cox, is a nightmare scenario for all of us.
What do the climate models tell us about a world that's 3 degrees warmer than pre-industrial times?
When you get to 3 degrees, you're talking about transforming the planet. Talking about a world that would not have been as warm as this for at least 500,000 years, and certainly probably longer than that. And as you do that, as you push the system further and further away, there's more chance that it undergoes what are called tipping points, or abrupt changes or steps in the system, where the change is fast, so fast that it's quite difficult to adapt to.
So there's various tipping points, but one of them's here in the Amazon, isn't there?
Yeah, we're concerned that under global warming we could extend the dry season in the Amazon basin, and when that happens, what can occur is that you get fires in the forest that change the landscape, and once you have a fire, the forest can't get back in, so you change the forest forever. about 10 years worth of emissions stored up in the vegetation, the soils in the Amazon basin. And of course it will have an impact locally on people and on wildlife. One of the most diverse ecosystems on Earth will be affected. The tropics and the Amazon basin in particular is kind of an engine for the climate system. So if you change something like this, you potentially change weather patterns across the globe, and particularly in mid-latitude regions like Europe and North America.
So what kind of things might we expect, say, in the UK as a result of burning the Amazon?
Well, we might expect, for example, to have an impact on storms because they're born in the tropical oceans, so you might have an impact on storm intensity like hurricanes, but also impacts on general weather patterns because it will change the way energy is distributed around the globe by weather patterns.
It's amazing, isn't it, when you think that something on the other side of the world affects us on our doorstep?
Absolutely, everything's connected together through the way the system operates. Another of the tipping points we're concerned about as we push the world beyond 3 degrees is the possibility that we could release these vast quantities of greenhouse gases that are currently locked up in frozen soils. And this band spreads all the way from Alaska around to Siberia.
So we're talking about the permafrost.
That's right. There's evidence already that the permafrost is beginning to melt because of global warming to date. And if that happens, if it continues to happen, we could release 1,500 billion tonnes of carbon that's locked up in those soils. That's 150 times what we emit each year.
And that's not all that's getting released, because I know methane's coming out there. I mean, how significant is that?
Well, if it comes out as methane, it's much worse still, because each molecule of methane is 20 times as powerful as a greenhouse gas as each molecule of carbon dioxide. It comes out as methane, we've got a real problem. Many people see the store of carbon in the higher latitudes as a kind of time bomb for that reason.
And it's not just the permafrost that's the problem, is it? Because what would 3 degrees of warming do for, say, the ice sheets like Greenland?
Well, we're especially concerned about Greenland. Many scientists actually believe that 3 degrees is beyond the tipping point for Greenland. When you get to that level, you start to melt the ice sheet. It's like a slippery slope because you then lubricate the underside of the ice sheet and you lose ice into the sea. Because it was on the land originally, it raises sea levels. If you melted it all, you'd have a 7-metre sea level rise globally.
You know, that's 23 feet. That changes the geography of a lot of the world's coast.
And it may take, and we're not sure whether it's going to take thousands of years or hundreds of years. There's evidence that it's happening quicker than we originally thought. Even if it takes a long time, it changes the world. There's Florida, for example, where the map is completely changed by that sort of rise. Even in Europe, where we've got low-level lands that will be flooded unless we had sea defences that were extraordinary. And, of course, Bangladesh, where millions of people are susceptible to that sort of sea level rise.
And that ice melting's kind of unstoppable, isn't it?
Certainly there's a vicious circle. So when you melt the ice, which is bright, or the snow, then you generally expose something darker underneath. More sunlight is absorbed, which means the planet warms up more, which means you get more melting. So there's a vicious circle that tends to amplify the process once it's got started.
It seems like this melting in places like Greenland's almost a double whammy. It gives you the sea level rise, and if that's not bad enough, it accentuates the warming.
That's right.
So if we reach a 3 degree plus warmer world, we may have to respond with science on a planetary scale by the massive manipulation of the Earth's environment, geoengineering. If we lose the polar ice caps in Greenland, we'll need to recreate their cooling effect.
In hot parts of the world, people have long understood the albedo effect and painted their houses white to reflect sunlight. So if we adopted the same idea for cities throughout the world, is this what they would look like? Some scientists have even suggested that plants could be engineered to reflect sunlight. It all seems pretty extreme, although one study estimated that if we whitened our towns and crops, it could counteract about a third of the warming we're currently causing. And there are other drastic geoengineering solutions now being contemplated. One involves a kind of war on the atmosphere.
If we need to use emergency measures to bring the temperature down, one option is to fire sulfates into the atmosphere.
It's an idea based on volcanic activity. When Mount Pinatubo erupted in 1991, it ejected millions of tons of sulfate particles into the atmosphere. These formed an atmospheric sun shield, and over the next year, there was a massive drop in the average global temperature by over 0.5 degrees. But if we were to fire sulfates into the air, we could do serious damage to the ozone layer. In fact, we won't really know unless we try it, and that's a huge risk. Other extreme solutions are being proposed. Some sound like science fiction. One involves launching millions of mirrors into orbit to reflect sunlight away from the Earth.
Geoengineering seems like a terrifying prospect. It's hugely expensive and risky. It could create more problems than it's actually trying to solve. So we want to avoid getting to the point where we'd have to use it. But that means we all have to take responsibility. Every one of us needs to use less energy. Our politicians need to get braver. And there's all this science and technology being developed around the planet to try help. We have to start using it wisely, and we have to start using it now.
We've only got a window of a few years to avoid truly dangerous climate change. The longer we take before changing direction, the harder it will get and the more severe the consequences. Previous generations fought world wars for independence and freedom. It looks like our generation's great battle will be with global warming.
The Natural World is here on BBC HD tomorrow night at 10. And coming up next tonight, Andrew Graham Dixon takes a fresh look at Russian art in a brand new series.